Alright, here we have Diego runs a 10-kilometer race and keeps track of his speed. His speed is a function of his distance. What was Diego's speed at the 7-kilometer mark in the race? So we're going to find 7 kilometers. We can go up and we can go over 11 kilometers per second. Sorry about the whining, that's my dog. Where was Diego when he was going the fastest during the race? So we can see the fastest is up here, and it is at 6 kilometers in the race. And how many times during the race did Diego run 10 kilometers per hour? Looking at 10 kilometers per hour, he does it once, twice, 3 times, 4 times, and 5 times. So 5 times. You're fine, Callie. Alright, going on to number 2. Jenny went on a 15-hour hike. Her distance in miles is a function of time in hours. What was Jenny's rate of speed in miles per hour for segment A? So looking at segment A, we want to find how many miles she traveled per hour. So we can basically make slope triangles here. We can see it went up 8 and went over 4. So she went 8 miles over 4 hours. And when we simplify that, that is 2 miles per hour. Segment B, once again, we're creating a slope triangle. It goes up 2 over 4. So it's 2 miles over 4 hours. And that's 0.5 miles per hour. Another slope triangle for C. It goes down 1, 2, 3, 4, 5. It goes over 1. So that's 5 miles over 1 hour, which is 5 miles per hour. And the last one, D, this segment right here, it goes down 1, 2, 3, 4, 5, and goes over 2. So 5 miles over 2 hours, and that is 2.5 miles per hour. Alright, looking at 3, draw a graph of Sarah's distance from her home as a function of time for this situation. Sarah biked to her neighbor's house, where she hung out for a while, then biked far away to a grocery store, picked up some groceries, and then biked back home. So here we're going to have time. We can say this is hours. You can also say minutes as well. And then here we have distance from her home. So Sarah biked to her neighbor's house, where she hung out for a while, then biked far away to the grocery store, spent some time at the grocery store, and then biked back home. Alright, looking at 4. Noah and Maria deposit money into their savings account each week. The amount of money Noah deposited each week is shown in the graph. The amount of money Maria deposited each week is shown in the table. So this is Noah and this is Maria. How much does Noah deposit each week? Well, if we look at it, it's going up 10 every 2 weeks. So $10 every 2 weeks, so that's $5 a week. And what was his starting amount? We can see that it's $60. How much does Maria deposit each week? Maria's going 75 to 78, and these are being added by 3. So Maria's depositing $3 a week. Now her starting amount, we would think it's 75, however, starting would be at week 0, and if we notice it's a +3 trend, so that would be 72. When will both Noah and Maria have the same amount of money in the same number of weeks? We can set up an equation, or you can continue the table. We continue the table, we have 5 and 87, 6 and 90. And then we can see here at Noah, at 6 weeks, he has 90. So when will they both have the same amount? At 6 weeks, they will have $90. Also, too, we can set up an equation. If this is Noah's, 5x plus 60 is equal to, now Maria, 3x plus 72. We can subtract 3x from each side. And we get 2x plus 60 is equal to 72. And then we can subtract 60 from each side. So we get 2x is equal to 12, divide by our coefficient, and we get x is equal to 6. And there we go, we get 6 weeks.